All right, 15 and 16 are asking us something a little bit different than domain and range. They're talking about end behavior. So we want to know what's happening on the left, referring to this one, and then what's happening on the right, referring to your right arrow. For end behavior, if you remember, it always has the same notation. We say as x goes to negative infinity, meaning on the left. See how it's headed towards negative infinity. Oh, negative. And then it's asking you what's happening to your y values. Well, in this case, it's not going up forever. It's approaching that asymptote that we talked about, and that asymptote is a horizontal line at 5. So on the left, it's approaching 5. On the right, so this time, notice I'm not going to use the negative. I'm going to say towards positive infinity. So I'm referring to my x-axis numbers as they grow. What's happening to our y value? Well, because this arrow is pointing down, we're going to say that it's approaching negative infinity. But just remember, the first part of that notation is all the same. So this will be written the same every single time. It's just the 5 and the infinity that may change. All right, so again, let's write that notation as x goes to negative infinity. We are going to describe what's happening to the y values. As x goes to positive infinity, again, we're just describing what's happening on the right. So this negative infinity, meaning on the left, I'm referring to that arrow, and because that arrow is pointing up, we're going to say positive infinity. When we are looking at the right side, we are referring to this right arrow. So this is meaning right. That right arrow is not going down forever. It's approaching this -1, that horizontal line. So we're going to say the y values are approaching -1. Now, in this one, they give you the general model. They'll give you the general model on the actual test. So you don't have to worry about putting all of those formulas with the compounded interest and all of that. You just need to know how to use it. Okay, so this is always my initial amount, or whatever I started with. So here they say that they start with 40 million acres. You don't have to put all of the zeros and the commas. You're just saying 40 million. So we're going to say minus the rate. Well, if you remember, to get the actual rate, you have to move the decimal left twice. So you're going to insert a 0. And then it says, in what year will the acreage reach 30 million? So you have to decide, is 30 million a time? No. 30 million is the ending amount of acres that we want to end up with. So we actually need to look for t. What I'm going to do first is combine my like terms. So I'm going to say 30 equals 40 times 0.95 to the power of t. From there, I'm going to divide by 40. So on the left, I'm going to get 0.75. Now, if you remember from the front side of this worksheet, if I could not turn them into the same base, we saw this example in number 6. The 14 could not turn into a 100. So we had to take the log of both sides. We took the log of 14 and the log of 100. By taking the log, it allows the exponent to fall to the front from our expanding rule. So that's what we're going to do here. We can't turn 0.95 or 0.75 into the same thing. So we're going to take the log of 0.75, the log of 0.95, and that t falls to the front when we use that log. We're going to divide by log of 0.95. And then we'll have t. .61. Now remember, it says in what year. So what we need to do then is take 1963 and we're going to add 5 years to it, making it 1968.